Hello everyone, welcome to our channel. In this video, we will be going over how to evaluate our machine learning model that we'll create. In this video, we will use a model, specifically linear regression, train the data and test the model how it performs and see a couple of evaluation metrics along the way. So without further ado, let's get started. First, let me create a section as always. It will be, let's say, evaluation or evaluate algorithm. Next, let's split our dataset into two parts, X and Y. X and Y. So X will be the list of our features that we want to train our model on, and Y will be the attribute or the feature that we are trying to predict. In this case, the ERP for the CPU. So data.ilog. Now, if you remember, we have 1 to 10 columns, out of which first and second are objects, VU, N, and MOD, which is the vendor and the model. So we will skip those two columns. We will take from MY city, which is the third column indexed 2, till PRP. Okay. So let us do it, colon, comma, so and 2 colon minus 1. So the left side of the comma is denoting that we need to take up all the rows of the dataset. And the right part, 2 colon minus 1, denotes that we are skipping 0th and first column till minus 1, which is the till second last column. And this will be pretty easy. I log filling all the rows and columns of the last. So this is exclusive. So the right hand side or the right part of the column is exclusive. Hence it excludes the last column. We'll execute it. Okay, good. Next, we will split our dataset into train and test portions. For this, we need to import a library, a method from the scikit-learn library. So from scikit-learn.model selection, import train test split. Next, we will use this train test split. First, we pass in X, which is data, Y, which is the feature data, and the test size will respond to. Now, this is not a categorical ML model where you need to predict a class for each of the instance. Hence, we are not using stratify, which is one of the parameters that you would typically use in a categorical project. So it returns 4 values, which will be X train, X test, Y train, and Y test. Awesome. Let's print the shape as well, post and before and after the split. X test 209.2, which means 20% would be in the data tester data, 42, and the remaining 167 are in the trained data. Next, we will use one of the simplest of regression models, which is a linear regression that is imported from scikit-learn linear model. Import linear regression. And so let's use that model. Model equals linear regression. And we will also fit our data, which is the train and test data. Not test, train and Y train. So X is the data and Y is the feature data labels. And next, we will find out what is the training accuracy for which, and since it is a regression based model, we can use multiple attributes or evaluation metrics. But for now, let us use scikit-learn from scikit-learn metrics and mean absolute error and R2 score. So it should be fine. Come back to our evaluate algorithm. Then we will first find out the predictions from our training model, from our model on the training dataset. Model.predict X train, and the metrics that we want to use for finding that evaluating our model will be MAE. So MAE, which is the mean absolute error. So mean absolute error, and the other one is R2 or R square, which is R2 underscore score. For these metrics, we pass on a loop our metric in metrics and print it out as metric for the Y train, which is the actual labeled data, and what our model predicted that data, and we'll print it out like this format, name and result. So the MAE, which is the absolute error for our training model, is 19.08, which means on average there is a deviation of 19 units, and R2 being 0.96. Now one insight on R2 is the closer R2, the range of R2 lies from 0 to 1, 0 implying completely misfit and 1 implying perfect fit. So ideally the value would be between 0 and 1. The more closer to 1, the better the model is. And since the value is quite high, basically implies that the model is pretty straightforward, and hopefully we can test it to make sure it is working correctly. So model.predict will do the same this time with test data. We have already taken up the metrics, so that is fine. And here I'll pass the y test and the print test, which the model has predicted. 22. So you can see on average the deviation is higher compared to our training data, and the R2 result is 0.86, which is, to be honest, on the lower end compared to our training. But see, 0.86, fair enough. Awesome. So I think those were the parts that we wanted to cover in this video. We'll wrap up the video here, and in the next part we will take a look on how to finalize the model for the dataset, CPU, ERP dataset. Thanks for watching. Bye-bye.